This is the Turf Zone Podcast, your central information and news hub, bringing together professionals from turf associations across multiple states to share things to help you in your business. Brought to you in partnership with our friends at the Pennsylvania Turfgrass Council. Now, let's get in the zone.
Welcome to the Turf Zone. In this episode of Pennsylvania Turfgrass, we feature an article titled, Consider the Source, How and Why Tissue Testing Delivers, written by Max Schlossberg, Ph.D., Associate Professor of Turfgrass Nutrition and Soil Fertility at the PSU Center for Turfgrass Science. As turfgrass managers, understanding the nutritional requirements of our turf and staying abreast of its nutritional status comprise important responsibilities. The methods by which we do so are varied and generally coined fertility or nutritional assessment techniques. One of these techniques, soil testing, was the topic of a cover article in the fall 2016 Pennsylvania Turfgrass issue. Tissue testing is the nutritional assessment of a plant through sampling of its vegetative tissue, followed by elemental analysis in an agricultural laboratory. The next step is to interpret the analysis results, which involves characterization of nutrient levels by keyword or index. Last is the recommendation step, typically comprising 0 or more fertilizer treatments recommended to reverse current or pending deficiencies. Why is tissue testing an effective nutritional assessment technique? Reason 1. Because it is a direct analysis of the biomass we foster, revere, and defend. This morning's clippings were yesterday's canopy, so how wouldn't they contain valuable information? Despite reading several popular Twitter feeds, I've yet to discover a valid answer. If your health declined and you sought medical help, which doctor would you prefer? The one who insists on examining you, or the one who insists on examining your living conditions? Relative to dicotyledonous angiosperms, grasses are simple plants that distribute acquired nutrients across vegetation per local concentration gradient. As a benefactor of robust research and reporting, our discipline maintains species-specific expectations for leaf concentration of 14 mineral plant essential nutrients and arguably 3 additional elements. Ostensibly, the same cannot be said of current fertility assessments of turfgrass soil. Reason 2. Because the full panel of turfgrass tissue nutrient concentrations readily implicate contamination, it intrinsically supports quality assurance and control efforts. Of course, discovering a clipping sample to be contaminated by fertilizer or soil is not a desired outcome. Yet even experienced scientists commit sampling errors and know well enough to jettison tainted observations from the set. This is because agronomists recognize the irreplaceability of plant essential nutrients and the likelihood of a faultily derived fertilizer recommendation consuming valuable time and resources, all while not remedying jack. And yes, irreplaceability is a word. I liken a full panel of turf clipping nutrient levels to a figure 8 knot, the knot most used by climbers to secure their harnesses. Do you know why the figure 8 knot is most used? Because its proper configuration is more readily confirmed than every alternative. Allegorically speaking, it is better to discover the error and restart than plow on oblivious and die. For those readers who took Turf 435 in residence, you may like that analogy as much as my photorespiration one. Perhaps not. Full test results of single, standalone soil samples do not afford equivalent insight or indication of sample contamination. Tissue sampling. As with soil testing, the sampling step is an incredibly important component of the tissue testing process. Hence, the following guidelines to consider when sampling turfgrass tissue. Collect a comprehensive sample set. If you have 1 or 2 fragile greens out of 20, or 1 problematic field in a complex of 4, by all means, tissue sample these suspect systems. However, be sure to also sample tissue from 1 or 2 of your identically fertilized and healthy systems. It is helpful to know the extent to which the healthy systems are responding to your fertilizer program. Securing a nutritional benchmark from healthy systems will help you determine whether the problematic system is suffering from a unique edaphic or cultural issue, or whether the healthier systems are steadily digressing to the problematic condition. Obtain a time array instead of a point. Growth rate is highly influenced by temperature, ET, and soil water. When plants are rapidly transpiring, they assimilate primarily mass flow nutrients, excluding those nutrients which move to the root by diffusion and/or biological facilitation. Furthermore, the tissue growth can surge with uptake and dilute less mobile nutrients. Therefore, subsample on multiple dates, say Monday, then Thursday, then Saturday. Homogenize the composite sample from that turfgrass system and submit as representative of the whole week. This approach is already used by golf course superintendents who recognize the pitfalls of over-irrigation, employ BGRs, and cannot obtain enough clippings in a single greens mowing event. I know who you are, and I hope you never change. Avoid contamination. For those continuing the long-honored tradition of assessing growth by clipping volume, kudos. The foremost benefit of clip vol vigor assessment includes prompt receipt of clear results immune from soil or sand contamination. On the contrary, the accuracy of leaf clipping nutritional analysis is highly dependent upon sample integrity. Why? Because dry leaf clippings have very low mass relative to sand and soil particles and/or fertilizer prills. While collecting clippings from recently dragged or brushed swards generally reduces the likelihood of particulate contamination, avoid collecting tissue samples within 4 mows of a top dressing event. Do not collect tissue samples immediately following a fertilizer application. Following a foliar fertilizer application, wait until either a significant rainfall or irrigation event has occurred or the turfgrass has been mowed twice. If a granular fertilizer has recently been applied, then wait at least a week to collect clippings for nutritional analysis. Fortunately, recent irrigation by low-quality effluent does not comprise a significant contamination risk. Processing. Dried clippings are most stable and analysis-ready. Taking the extra time to air dry your tissue samples, ideally in a dependably clean room, helps ensure quality results. If impractical, consider oven drying the tissue at very low temperature. Research-grade tissue drying is done at temperatures less than 180 degrees Fahrenheit. Some nitrogen forms volatilize at temps above 300 Fahrenheit, inciting underreporting of tissue in. If you are in a hurry and must submit moist clippings, consider overnight mail and alert the lab of their condition. Submission. In the final stage of preparing the sample for shipment, shuffle the dry clippings on a 1 mm to 1.7 mm mesh screen, a number 8 to number 14 sieve size, or on a clean, smooth, sloping surface. Avoid shoveling dry clippings into the mailer or bag. Use multiple pinched lifts to transfer the dry clippings instead. Most labs require 2 cups dry leaf clippings, yes, talking cooking measurements, per full analysis report. Tissue analysis. Most labs will analyze tissue samples for most or all plant essential nutrients. The Penn State Ag Analytical Serve Lab doesn't offer tissue analysis of chlorine, molybdenum, or nickel, but includes sodium and aluminum at no extra charge. Reporting aluminum levels on a tissue test report comprises added value despite it not being an essential nutrient. The reason? Aluminum is a common component of clay minerals, and elevated levels of leaf aluminum indicate sample contamination by soil. Interpretation and recommendation. Given a contaminant-free sample was analyzed, tissue test results routinely deliver valuable information. Tissue N level is particularly useful in assessing current fertilizer N availability as well as potential disease susceptibility. Penn State field research indicates creeping bentgrass systems having less than 4.2% leaf N in dry clippings are otherwise more susceptible to dollar spot. Similarly, leaf-in the 3 to 4% mass range of dry clippings collected from annual bluegrass screens indirectly relate to anthracnose susceptibility. Many overt soil testing proponents discount tissue testing as a mere snapshot in time. Unconvinced that's a bad thing, I encourage Penn State students and alumni to embrace high-resolution technology in support of effective decision-making, particularly June through August. Another reason N concentration sits atop the tissue test report is accumulation of several other plant essential nutrients interact with N fertilization. For example, potassium level in turfgrass clippings often relates directly to N concentration, even when target soil K levels are maintained or exceeded. On the contrary, phosphorus level in clippings often inversely relates to leaf N level, even across plots showing equivalent soil P availability. These interactions should be considered when interpreting your tissue test results. In all fairness, deficiencies in tissue test results interpretation do currently exist. Many studies have shown different cultivars of turfgrass accumulate varied levels of nutrients, even when growing on common soil and receiving an identical fertilizer regimen. Thus, the extent to which phenotype governs nutrient uptake and accumulation remains an important objective of future turfgrass field research. For all figures and resources associated with this article, visit our show notes. And don't miss an episode of Pennsylvania Turfgrass. Subscribe on Apple Podcasts, Spotify, or wherever you get your podcasts. You can also visit us at theturfzone.com.
You've been listening to The Turf Zone. For more episodes of The Turf Zone, visit theturfzone.com and subscribe on Apple Podcasts, Stitcher, or your favorite podcast app.